Hi thinkers, welcome to the data structures in Java course on ThinkX Academy. In this module 2, we are going to start with the array data structure. So we are going to cover all the important conceptual idea behind array data structure. We are going to use the array data structure in stacks, queues, heaps, hash tables. So there are a bunch of other data structures also there where we are going to use arrays. So it's important to study arrays. You're going to encounter a lot of coding problems that are asked in interviews related to arrays. So let's start with the arrays. Let's try to understand what is the concept behind arrays. So the first important thing about array is that it is a collection of elements with the same data type. So let's assume that we have a data. Here you can see I have taken an example 10, 11, 5, 6, 12, 24. So this is the data that we have. So we can say that this data is a collection of elements and they have the same data type. So you can see that all of them have the same data type, which is integers. So it is important that when we are trying to create an array, we create an array with the same data type and all the elements should have the same common property, which is the same data type. What is the objective behind this? The objective behind this is to actually create a data which actually resembles some common property. Data structure, which is array, is stored in memory and it is stored in continuous memory. So we have already studied that memory is the main memory, which is the RAM, and RAM is allocated in certain blocks and all the blocks have some physical address associated with it. Here, for the sake of example, I'm assuming that the memory location of this block is 2001, then 2, 3, 4, 5, 6. So the first question that comes in our mind is why array is stored in such a way, why it is stored in a continuous memory block. Now this is a feature of arrays and this feature gives us a very important advantage, which is we can access any element inside this array very quickly. The reason why how we can do that is that whenever you create an array, automatically it will have indexes assigned to it. So this array has 6 elements. Array indexing starts from 0. So here in the red color, you can see that it starts from 0, then 1, 2, 3, 4, and 5. So in this way, we are going to create an array and each and every array has an index. We do not need to specify the index. Index is already specified whenever we create an array. So here you can see an example of an array, how we can create this array in Java. So int is actually the data type here. So you can see here, this actually is the data type and it is common for all the elements. So all these elements should have the integer data type and array is defined in this manner. So you can see that ARR is actually the array and it is followed by these square braces here. So square brackets means that this is actually an array and it has all these properties and these curly braces is a set of all these elements. Any element of the array can be accessed using the index position, which I've already told you here. So let's say I want to find out what is the value of the array at the third index, right? So the way to do is very simple. I will write array, which is ARR. Then I will start a square bracket and I will say that I want to access position 3. Now remember that position 3 is actually the 4th element inside of the array. The reason is because the array indexing starts from 0. So here I've written this very important point and you have to remember this always, that it starts from the 0th position. So I can actually print this out using system.print.out.println. So that way I can actually print this value, which is 6. There is one more interesting way to define an array. Let's suppose that we do not know the elements yet, but we know that the elements are 6. So you can see here that there are 6 elements. So what I can do is, if I don't know the elements, I can actually create a array, integer array, new, which is the keyword, and int array 6 here. So 6 specifies that there are 6 elements inside of this array. So these are the 6 continuous blocks that will be allocated, but no data will be here, right? So how can we assign the data at these positions? The way to do is array, then provide the index here, right? So this actually is the index, which is here. And this is actually the value. So in this way, we can reassign also and update the value of an array. So let's say I want to reassign the value at the position 3 to, let's say, 1. So the way to do is very simple. I'm going to write array 3 equals to 1. So this is actually very fast. This updation, or you can say the reassignment, is very fast. The question arises why it is fast. It is fast because the CPU already know that if you want to access the third element, what it is going to do is It knows that the array starts at this position. It will automatically add 3 positions to the memory address, and it can automatically access the memory location, and it can access the data very easily. So the question why arrays can be used, where you can use arrays, is when you want to access any element very fast. So you can do that using that. Now there are some disadvantages of arrays. First of all, whenever you are creating an array, you will have to specify the number of elements that will be there inside of the array. Here it is 6. This is a fixed size, right? So once you have created an array, there is no way to expand this array. There is a actually dynamic array concept also, but we are not going to touch that here. Arrays have a fixed size. It means that once you have defined 6 elements, there will be only 6 elements there. So if I want to add an element here, I will have to create a new array, and then I will have to store the elements of this array into that, which we can call as array 2, and then we can perform the insertion. So insertion is not possible within this array. So this is a major drawback. This drawback will be actually, we can say that it will be implemented in using linked list, which we will study in the next module. Now there is an important concept of deletion. So whenever we are studying about data structures, we study these 3 important operations. The first one is insertion, the second one is deletion, and then we understand how can we access a particular element, and the last one, which is very important, is traversal. The reason why we do traversal is to perform search operation. So let's say there is a problem which says that you want to insert a particular element after a given element. So we will first perform the search, and after that we're going to insert it there. So you can see that it has a faster access. It takes a time complexity of big O of 1. So big O of 1 is a very good time complexity, and it is a constant time complexity. So in a very constant time, you can access any element. Deletion, talking about deletion, if I want to delete an element here, let's say I want to delete 5 from this one. So what I want is I want the array to have only these elements, which is I want the array to have 10, 11, I want to delete 5, 6 will be here, then we have 12 and 24. So if I want to perform this deletion, what I will have to do is I will have to do a swapping. So I will create a loop that will start from here and it will go till the end. At each position, I'm going to swap these values. So I will swap these 2 values. This will become 6 and this will become 5. Then again, I will perform the swapping and this will become 5 and this will become 12. And then again, I will do the swapping. This will become 24 and this will become 5. And what I will do is I will decrement the, right, it will be from 0, 1, 2, 3, 4. So I will create a for loop that goes from 0 to n minus 1 when we want to perform a deletion. Now, an important point here is that although we are actually logically, we can see that the element has been deleted. We are only considering these 4 positions, but you can see that the element is actually there and it will have a memory allocated. This is a huge problem because once you have created an array, there is no way to expand the array and there is also no way to shrink that array. We can do this deletion only logically, and we can perform insertion only by creating another dummy array which is in bigger length, and we can put all these elements in that, and then we can perform the insertion. So this is a huge problem with arrays, that it is fixed in nature. So there is one more important thing, which is traversal. So let's say I want to traverse from one element to the another. In the best case, which is the case when we have got the element at the very first position, we are going to say that the best case time complexity is big O of 1, which is again a constant time complexity. But just think about the worst case. In the worst case, let's say I want to search the element 5, right? Or let's say I want to search the element 24. So here you can see 24 is at the nth position. So in the worst case, the time complexity to reach here will be big O of n, right? Because we will have to go to this position, then this one, and so on. This is very inefficient in nature, and there are a lot of reasons why we can optimize this using other data structures. Because in the worst case, if you have a data which is very large, let's say you have a large number of elements, in that scenario, you will get if you want to perform search, you will have to make sure that you're using some good algorithm to be able to search, or else it will give you a worse time complexity of big O of n. So that's very important thing about the array data structure, and this is how we can access element and perform deletions. Deletion is not possible because once a position is allocated, there is no way to deallocate this position. So it is going to take some space in the memory, and in the very first module, I've taught you that memory is a very crucial resource. we want the memory to be very efficient, right? Because it is a huge resource, it consumes electricity, and if you're going to store the elements, if you want to remove an element, it becomes very hefty. There is one more interesting disadvantage, that if the elements are, if we have a large data, it is possible that in the memory there are other processes also using the memory. So in that case, you might not be able to get continuous allocation. You might not be able to get continuous blocks which are empty. Maybe there is some other process which is occupying some space here in between. So in that case also, creating arrays is actually disadvantageous. But we will study stacks, queues, heaps, and different data structures that will use arrays, and we will see how we can actually remove these disadvantages using linked list and other data structures. In the next tutorial, which will be 2.1, we will solve some of the problems related to the array data structure, which will start from basic to intermediate to advanced. So we are going to solve 3 problems related to this data structure. So hope that you have liked this tutorial and you have understood this concept. Make sure to check out the notes and all the codes on our website thinkxacademy.com, and also follow us on our social media ThinkX Academy on Instagram. You can also like the video and share the video with other students to also help others also, and also help us to grow this channel. So thanks for watching. We'll see you in the next tutorial.